This episode of the Fire Sprinkler Podcast is brought to you by Engineered Corrosion Solutions. Engineered Corrosion Solutions is the leading provider of corrosion management products and services in the fire protection industry. ECS sells direct to fire sprinkler contractors and offers nitrogen solutions for both wet and dry pipe systems. Their patented ECS ejector automatic air vent meets the new NFPA 13 venting requirement, and unlike other available products, it does not require plumbing to drain. You can find ECS online at ecscorrosion.com or email them at sales@ecscorrosion.com. Welcome to the Fire Sprinkler Podcast with Chris Logan. Hey everybody, thanks for tuning in to the Fire Sprinkler Podcast. On today's episode, we have Lucas Kirn from Engineered Corrosion Solutions. Lucas, how are you today?
I'm doing well. How about yourself?
It's still pretty early in the day, but so far so good. You have reached out because you wanted to talk about the history of corrosion and some of the corrosion solutions that you guys offer in the fire sprinkler industry today. What's the difference now as opposed to 15, 20 years ago as far as corrosion is concerned?
That's a great question and a very common one that we run into because a lot of fitters that have been out in the field for a long time, one of kind of their common observations is, that I feel like this didn't used to be a problem, or at least we never really noticed it until more recently. And there's, multiple factors that really affect that. I guess if we kind of back up to kind of historically, where kind of the boom of fire sprinkler system construction started, you had your model building codes developed, back in the 70s, and then probably around the early 80s and beyond is when you really started to see, a boom in installation and construction of fire sprinkler systems. Right. And so one of the simplest factor involved is just time. Corrosion takes time. It is a gradual process. And so there's just a lot of, early in the early days, systems just weren't old enough to really see any problems. And so now what we're running into is we're starting to see this wave of issues with these middle-aged to older systems that have finally reached a point where, okay, there's been enough corrosion that we're starting to see the problems related to it. The other factor is, something that the most primitive form of corrosion protection is your pipe schedule. So if you're using Schedule 40 pipe, which was the standard early on, a few decades ago, right. It's going to take a lot longer to corrode through or have a failure in a Schedule 40 pipe compared to a Schedule 10.
Yeah, and using a larger schedule pipe doesn't necessarily prevent corrosion. It just takes longer for it to become obvious and apparent.
Absolutely. Yeah. There's not Schedule 40 pipe does not, like you said, does not actually stop or prevent any type of corrosion. It just means it's going to take longer to eat through the pipe wall. Right. And so there's, like I said, there's multiple factors involved. Some of it had to do with, the materials being used, the age of the systems. Another factor is that we, as the industry has evolved, we've really gotten more stringent about the testing and maintenance of these systems. And right. While that is absolutely a necessity to make sure that these systems operate properly, they are a life safety system. But the increased testing, inspection and maintenance on these systems indirectly leads to additional corrosion, because when you increase, the level of activity, and what I mean by that is if you keep introducing fresh oxygen or fresh water into a system, it's actually going to accelerate or restart that corrosion process. So, like I said, there's a number of factors involved, and then the final one is just a more of an awareness thing. People may have been replacing damaged pipe for 20 or 30 years, but didn't really think much of it until there's been just an overall increased awareness within the industry that corrosion is a real issue and something that needs to be addressed. So more people are thinking about it and recognizing it when they see it.
Right. So it's not so much as it's becoming more obvious. It's that people are maybe paying more attention to it. It is yes. becoming, it's becoming more of a problem because of the increased inspection, testing, and maintenance requirements, i.e., introducing the oxygen into the system. But patching and repairing pipe has been around forever. So
Absolutely.
yeah, it hasn't really been a difference. Okay.
Right.
So as far as dealing with corrosion, there's a lot of things, talking about MIC, talking about galvanized pipe, things like that. What are some of the issues, and what are some of the things that people think happen, like myths? What are the myths
Yeah.
associated with corrosion?
Sure. So probably the biggest one out there is almost everybody in the industry has heard the term MIC, which stands for microbiologically influenced corrosion.
Right.
And it implies that bacteria are either directly eating away at the pipe wall until it fails or creates a pinhole leak, or they're producing some sort of byproduct, like an acid maybe, that is actually eating away at the pipe. And while MIC is very much a real thing, I mean, it occurs in multiple types of mechanical systems.
Right.
Um, but we really first got when I first got involved with our company, um, our CEO had a background in corrosion in the oil and gas industry, and so he had a ton of experience with MIC, and he came into the industry kind of thinking. At the time, it was the most prevalent thought process behind corrosion was that it's all related to MIC, and so he started to look at it, and it only took him 30 or 60 days to start looking at all these issues that were coming up, and he's like, this isn't MIC, this isn't what I'm used to seeing when I was studying MIC. This is all just oxygen corrosion. And so really what we found is that while MIC is a real thing, it can occur in fire protection systems, but it is almost always a secondary factor. And what I mean
Right.
by that is you have to have some sort of chemical process start. And in this case, most of the time it's a oxygen corrosion reaction or oxidation. And then what can happen is the debris that's created from that reaction can actually help grow or help the proliferation of bacteria in the fire sprinkler system. And so
So
that's kind of where the industry got off in the weeds, 15, 20 years ago, when people started to think, like there's no good reason why these pipes would be corroding. They're solid metal. There's got to be it's got to be a bacteria problem or something. So they started taking samples from the systems, and what do you know? They found a lot of bacteria, but there wasn't really at that time a further analysis done to determine, is that bacteria in there actually causing the corrosion, or does it just happen to be in there because these systems are dirty and they're not sterile when they're first put in, and bacteria tends to grow everywhere, and actually the most common type of bacteria that we find in these systems are called iron related bacteria, and they actually use iron oxide as a food source. And iron oxide is just a product of oxygen corrosion. So as you can
mhm.
imagine, if you have an oxygen corrosion problem in your system, you're going to end up with a lot of bacteria in there as well.
Okay. So MIC necessarily doesn't always come from the water supply. It always comes from. It could potentially always come from. Oops, sorry, I'm getting some feedback here. The MIC doesn't always come from just the water supply. It has to come from some sort of internal corrosion from the get go.
Yeah, so basically what it starts with is these, like I said, these systems aren't sterile or disinfected when they're first installed. So you may start with a very small amount of bacteria that just kind of were in the system to begin with.
Are you telling
And
me that sprinkler water, when you drain a sprinkler system down and get that nice, tastes
chocolate
like,
milk.
smells like money, sprinkler smell, that's not sterile? This is
No,
mind
absolutely not. No,
mind
no.
blowing for me.
Yeah,
So we kind of breezed. You talked about the history of the owner of your company. Can we talk a little bit more about the history of Engineered Corrosion Solutions? When did you guys start, and how long have you guys been around for?
sure. So we've only been known as a company as Engineered Corrosion Solutions since 2013.
Okay.
But actually, we've been around since 2003. And so the original company was founded by a group of fire protection engineers that recognized that there was kind of this unmet need within the industry. They were starting to see a pattern of corrosion problems and premature failures in systems with some of their clients, and they saw an opportunity to kind of go out in the industry and form a company that really just focused on corrosion as a problem and try and provide solutions. And so that company was originally called Fire Protection Solutions Corrosion Management Inc., FPSCMI. And you can tell, since that just rolls right off the tongue, that was a name that was come up with by a group of engineers. Mm-hmm. So yeah, it was originally formed in 2003. But at the time, there still wasn't a great understanding of everything that was leading to the corrosion failures and what the best approach was. At the time, kind of the conventional wisdom was, if you're going to try and do anything with corrosion, you're going to try and use a biocide or a corrosion inhibitor. And so that's kind of where the company got started. And then, like I said, earlier, our current CEO, he came on board in 2008 and started really taking a more scientific look at the problem, recognized that it was pretty much all oxygen corrosion. I came in really just a few months after him as kind of the first fire protection engineer working for the company, and we started to develop a new solution, which involved the removal of oxygen. And so in some cases that involves the use of nitrogen to displace the oxygen. Other cases, like in wet systems, we're just trying to vent the air which contains oxygen out of the system. But that's kind of the history of the company. And then in 2013, we rebranded ourselves. We changed ownership. We still had all the same senior managers, and we kind of forged down this path where we really wanted to make everyone aware, provide that education to the industry of this being a real threat to these systems, a real problem, and we believed we had a viable solution for it.
So you mentioned there the venting of wet pipe systems. Let's talk a little bit about that. I know you guys, I just pulled up, you guys have an air relief valve listed and approved for NFPA 13 use in wet sprinkler systems. What is the purpose of that, and why did it become why did they include it in NFPA 13 back in 2016 to require air venting on wet sprinkler systems?
Sure. So I guess, taking a step back again to kind of some of the older methods and means on these fire sprinkler systems is on older systems, most of the time there was a remote inspector's test installed on these wet systems. And the best practice for the fitter was to go ahead and leave that remote inspector's test open while they were filling the system back up, charging it with water. And they'd go back to the remote inspector's test, and a lot of times it'd be spitting a mix of air and water, and until it started shooting out a steady stream of water, they wouldn't close it. And so what that did is it provided a manual means of venting the system. Well, I can't remember exactly which edition of 13, may have been the 99 edition or maybe even earlier, that allowed the inspector's test to be brought to the riser. So the AHJ didn't have to, head on a whole 200 to 300 feet over to the remote test, so they could just test it right at the riser. But what that did is it eliminated the manual means that everyone used to use to vent these systems, and now they were trapping, all this air. So, from a scientific perspective, not to try and get really down and dirty with the science, but basically, when a system is empty, it's sitting at atmospheric pressure, but it's filled with air, which is 21% oxygen. And as soon as you start flowing water into that system, that air, if it doesn't have anywhere to go, it just gets compressed into the remote ends and the high points of the system. So now you have these trapped pockets of gas in the system, nowhere for it to go. And, what happens is that oxygen will just react with the metal. It'll cause corrosion. And until all the oxygen in the system is consumed. So what we actually the automatic air vent is one of the first products that was ever developed by even our predecessor company, FPSCMI. We've since re-engineered and improved it over the years. But that was really one of the most basic, cost-effective approaches that we came up with that is still applicable today, is just put a vent on the system, a high point remote end of the system. We sell a redundant vent, which means it has 2 float valves in series, so it doesn't have to be plumbed to drain, so you don't have to worry about it being a leak risk. And literally it resets. It's a simple float that works with there's a buoyant float inside the chamber. When air passes through, it's not strong enough to raise that float and seal the orifice, but as soon as water hits it, that buoyant float raises up with the water and seats that orifice and immediately shuts it. And so what it does, it automatically resets every time you drain the system down. So it's a multi-use piece of equipment, and because it's already installed and will automatically vent and drain with the system, it's great because it takes the human effect or the potential human error out of the equation. Because obviously, if you have a manual vent, you have to rely on the fitter that's working on that system to know that there's a manual vent and to use it every time they fill the system.
And to bleed the proper amount of air out when he's filling the system instead of just, I've got water, shut that valve.
Right. Yeah. And in a vent, again, there's a ton of different types of systems out there and different designs and, different variables with the building construction you have to take into account. So obviously, one vent installed on one system can be a lot more effective than one vent installed on another system, depending on, the number of elevation changes you have in a system and the pitch of the system. And there's a lot of different factors. But what we do know is the correlation between oxygen removal and corrosion activity is directly proportional. So if you get rid of 50% of the trapped air in a system, you're going to reduce the corrosion activity in that system by 50%.
Oh, okay. I see. So we've talked a little bit about the venting of wet systems and things like that. What are the main causes of corrosion in sprinkler systems, both wet and dry?
So really,
we touched on it a little bit earlier, but I wanted everybody out there that doesn't already know, what to be looking for when they're installing systems and to make sure that they can take care of these systems properly.
Sure. Yeah. So really, in both types of systems, it's just a simple oxygen corrosion reaction or oxidation. Probably the best analogy I can give to people that would be most familiar with it is you go through a car wash, and as soon as it dries, you get some flash rust that shows up on your brake rotor. And so that's just a very quick example of it's more superficial. It's going to wear off as soon as you start driving and using your brakes, but that is the same type of reaction that's occurring in a fire sprinkler system. And so and the difference between wet and dry systems, it's the same mechanism of corrosion, but in wet systems, we have a limited amount of trapped air and oxygen and a lot of water. And so we see corrosion most likely to occur wherever you have trapped pockets of gas. And you have to basically, for that reaction to occur, you have to have air be at an air-water interface, because you need the oxygen to dissolve into the water and then react with the metal on the pipe. And then it basically takes a small piece of the pipe off the wall and forms iron oxide, and then it generally collects at the bottom of the pipe. And so over time, you can get a large collection of debris on the bottom of these pipes. In a dry system, the equation is kind of reversed in that you have almost an unlimited supply of oxygen because you generally have an air compressor on the system, but you have limited amounts of water. And as anybody who's worked on a dry system knows, none of them are ever truly dry. They all have pockets of trapped water. We all try and, even the best well-pitched systems are still going to have very small pools of trapped water, whether it's at the mechanical coupling or, in the main. Just if it's a larger system, it's just going to be gradually trickling back to the main drain at the riser. So there's always a certain amount of moisture and water in these dry systems, and really those systems are most likely to corrode at the low points where you have a small amount of trapped water and the oxygen reacting with that water to degrade the metal pipe.
Okay. Let's get into a little bit of the testing methods. How do you test to determine if you have corrosion in your system?
Sure. So what came out in NFPA 13 a while back may have been the 2002 edition that started to require testing of the source water. And unfortunately, we believe this was kind of a misguided approach where the thought process was, well, if we can get an early determination that the source water could potentially be corrosive, then we'll be able to better design around that or be proactive in the design of the system. And what we have found by and large is that all of the water throughout the country, throughout the US and throughout Canada, the vast majority of fire sprinkler systems are just fed from, a public municipal water supply.
Yep.
And all those water supplies are clean treated water, and they're not inherently corrosive. So really it's the reaction that takes place once the water enters that sprinkler system and not the actual source water itself that is corrosive. Obviously there's exceptions to every rule. I mean, if you're supplying a system with gray water or pond water, or from a reverse osmosis plant near the ocean or something like that, those are the 1% of the time when you may actually have corrosive water, but 99% of the time it's not the water that's entering the system that's corrosive. So that was kind of the initial start of corrosion testing in fire sprinkler systems. And then on top of that, people were testing for, MIC. They were trying to scrape deposits and sludge into bottles and sending them off to labs. And, I could tell you with a great amount of confidence that 3 out of every 4 samples that you're going to submit to a lab are going to come back with very high levels of bacteria. Because again, these systems aren't clean. They're already starting at a point of being inundated with bacteria, and they just continue to grow. So that's, again, not a very good indication of, what the actual corrosion problem is. So, we really believe that the best starting point for doing a corrosion test is taking a pipe sample from the system. Okay. And what I mean by that is if you either have, obviously, if you have a section of pipe that you've had to remove because it had a failure, that's a great place to start. Or we direct our customers to look at specific areas in the system and take a sample. So basically just cut out a section of pipe, 12, 18-inch section of pipe. We get it, we process it, we examine it. And believe it or not, just from looking at the types of metal loss, the type of pits that are forming in the system, we can differentiate whether it's an oxygen corrosion pit, whether it's bacteria, whether it's something unusual like an acid type of corrosion. And so by physically examining the pipe that was in the system is actually the best method to determine, what type of corrosion you have going on and how severe it is. Because if we know the age of the system, we can measure the pit depth, and then we can give you, your rough corrosion rate estimate on the system.
Okay, so two questions about what you just said. You mentioned that you had not so much specific areas, but recommended areas to remove the pipe for sampling. What are those areas that are more susceptible to corrosion, where you would like to see the samples taken if somebody were to send a sample to you?
Sure. On a dry system, it's generally easier to locate because really anywhere on, if you either have kind of an isolated low point on the system
Hmm.
that you know is going to collect some water, that would be a great location. If not, if it's relatively well pitched or a flat system, taking a section of main as you get closer to the riser is a great location because as this after you do a hydro test or there's a trip event, that water will still gradually continue to drain back towards the riser, and so that feed main near the riser is going to see the most amount of water passing back through it.
Yeah,
So
the
that'd be
water's gonna sit there the longest, essentially, right?
yes, yeah. And so what we're trying to do is look at the worst case point in the system, and on a wet system, we're generally going to recommend taking a section of branch line. And so, depending on how the system is designed, it may not always be apparent where's the highest point in the system where air might be trapped. But what we've, what fitters probably will recognize is if they open up a section of branch line, you can visibly tell where an air pocket has been because you can actually see a line on the side of the pipe that shows, okay, the air was above this line and the water was below it.
Oh
And
yeah, yeah,
so,
yeah.
yeah, so basically, if you can find a location near a high point in a wet system where you run into an air-water interface, sending us that section of pipe is going to be the most beneficial.
So when if I were to send you a sample of the pipe, I don't know if you want to give out or if this is considered a trade secret, but what is the differences you're looking for? Now, obviously, you guys are doing the study and the assessment, so you can make a more, a better decision. But based off the corrosion, what do you guys look for to determine if it's a MIC,
Hmm.
if it's MIC corrosion, or if it's just straight,
Sure.
corrosion from sprinkler pipe?
Yeah. So the when I mentioned like by looking at the types of pits, you can tell what type of corrosion is occurring. What we tend to see with oxygen corrosion is that these are very smooth pits that don't really have jagged edges, and because it wears away at the pipe over time. Whereas if it was mic or bacteria, what tends to happen is if you look at a pit and it looks like it's kind of plateaus into concentric circles around the initial point of or the deepest point, that's much more indicative of bacteria related corrosion or mic, because what happens is you start with your initial colony of bacteria, and then as it grows it grows outward fairly evenly in all directions, and you by the factor of repeated growth of these bacteria colonies, it tends to have these kind of concentric circles with more jagged edges around the pit. And then in terms of the other type of corrosion that we've seen, acid related corrosion, that tends to be a very narrow and deep type of pit. So oxygen pits are generally going to be wider and as wide as they are deep sometimes, whereas an acid pit is going to be almost like you took a hot needle and pushed it through the pipe wall.
Really?
Yes, and so that can be one of two things. At that point, we'd want to get some more information about the system because it could either mean, okay, we've got something in the system that's producing acid, such as a bacteria, or there is some other contamination in the system. And what we've actually found, we ran into this issue for the first time maybe 4 or 5 years ago, and since then we occasionally see it. It's actually related to antifreeze systems. So if you have a wet system that is attached to an antifreeze system, let's say you have a retailer that has an overhead wet system that also feeds an antifreeze loop that's protecting a canopy. If you don't have the proper separation between the systems, whether it be a backflow or check valve or something, and you get some seepage of the antifreeze solution back into your system, and that antifreeze is not maintained properly, what we found is that antifreeze over time will actually break down and form acids as a byproduct. So if you
Really?
have, yeah, so basically forms different types of carbonic acids. So if you're not properly maintaining an antifreeze system, it breaks down by a process called oxidative corrosion, which basically means it's a combination of high heat and oxygen that react with the antifreeze chemical and break it down and form acids as a byproduct. So it's kind of an unusual case, but we have run into it, and it's just one of those. We're all kind of engineers at heart in our company, and so we kind of actually get really excited when we see something new, because it means we kind of have to dig in and look into it more. And that, like I said, that popped up about 4 or 5 years ago and really surprised us, because before then we never really had a reason to look at antifreeze or any kind of byproducts related to it, and we learned something new.
Awesome. That's what was that word again? What was the
Thermo-oxidative corrosion.
thermo-oxidative corrosion? Okay,
Yep.
right on. I'm going to look a little bit more into that. That's interesting. So what happens is the antifreeze breaks down, and it breaks down into an acid.
Yes.
And it just gradually eats away at the pipe. Now, are you finding that type of corrosion? I'm just assuming because the acid, it actually it accelerates faster. Which type of corrosion do you guys find to be the the fastest growing and the most acceleration in sprinkler systems?
Really, it depends. I hate giving that answer because it's not really an answer, but there's multiple factors. There's multiple factors that go into the corrosion rate in a system. I mean, so in general, I guess I could break it down into kind of the types of systems that and kind of the general corrosion rate we see in them. I don't have a good feel for how quickly an antifreeze can corrode, because again, we only have a handful of samples in that type of application. But when you're looking at dry pre-action versus wet, we find that dry and pre-action systems will fail much more quickly than wet systems. Sorry, go ahead.
Go ahead. I did see a study recently. I think it was you guys that put it out, that said that dry sprinkler, the lifespan is now 20 years, 24 years under the right conditions.
I don't. I'm not sure if that was us that did that, but actually,
Okay.
what we found is that if we're talking just kind of Schedule 10 black steel pipe, a reasonable lifespan for a dry system now is maybe 10 to 15 years. You could actually even start seeing leaks as early as 5 years. And we haven't even really talked about galvanized pipe, but galvanized pipe, kind of contrary to conventional wisdom, will actually fail faster than black steel pipe in dry and pre-action systems.
Let's actually talk about that now, because
Sure.
that was kind of that was a big shock to me when I started digging into nitrogen and corrosion solutions and things like that. Was that galvanized pipe, contrary to popular belief, is actually the worst pipe you can put in a sprinkler system as far as corrosion is concerned.
Right. Yeah. So galvanized, for people listening who don't know, galvanized material or galvanized pipe is really just it's a piece of black steel metal that's been coated with a zinc metal coating. And there's a couple different methods of application, either hot dipped or electroplated. But either way, you end up with a base black steel component with a thin layer of zinc metal over the top of it. And, galvanized material is great at preventing atmospheric corrosion, external corrosion. We see it on guardrails and fence posts and flag poles, and they use it in, fire alarm and electrical for conduit. But what we found when we really started looking into it in fire sprinkler systems was it just wasn't holding up. that contrary to popular belief, we were like, why are we seeing such premature failure in galvanized piping systems?
Mhm.
And when we started to look into it more and do some research on it, we found that the only way that galvanized pipe or that zinc metal is truly effective at preventing corrosion is it cannot remain in a persistently moist or wet environment. It has to dry out at some point to kind of reform that protective layer that prevents corrosion, external corrosion.
Right.
And so what happens is in these dryer pre-action systems, you end up with anywhere from small to large trapped pools of water. And if it never dries out, it will very quickly degrade that zinc layer. And now what you have is basically corrosion looks for anomalies in fire sprinkler systems. Or I'm sorry, really in any application, corrosion looks for anomalies. And so all of a sudden what you have is an anomaly in the pipe wall where you have the breach of the zinc layer. Now you have your base black steel exposed, and all of the potential corrosion energy is going to focus on that anomaly. And what happens is we get pipe samples all the time where 98% of the surface of the pipe is still in good condition, but there's just one or two very deep and prominent pinholes in that pipe.
Right.
And so what happens is you get an accelerated corrosion activity right at that first breach in the galvanized layer, and it will corrode much more rapidly than it would in black steel, because in black steel you don't have the same type of anomaly occurring on the surface, and it will corrode much more uniformly wherever that trap pool of water is. So by comparison, if you were to hold a piece of corroded black steel pipe in one hand and a piece of corroded galvanized pipe in the other, what you'd see on your black steel pipe is almost like a trough that's kind of been cut out in the bottom of the pipe where the trapped water was, but there may not be a wall breach yet. Whereas in the galvanized pipe, most of it looks like it's still in very good shape, but you'll have a very deep pit that may have already breached the pipe wall. And so what the difference being is that in black steel systems, we'll end up seeing actually a lot more corrosion debris because we're actually corroding a lot more material because it corrodes more uniformly. But in galvanized pipe, while it doesn't produce as much corrosion byproduct and debris, it will actually form a pinhole leak much faster through the pipe wall. We've actually, sorry, I was just going to give one example.
Yep.
Is we were actually working on a project, a major international airport in the United States. They were going through a major renovation in their baggage handling areas, and they were installing brand new Schedule 10 galvanized dry pipe systems. And they actually had a failure within 12 months of a newly installed system.
12 months?
Yes, 12 months.
Wow.
Yeah.
So the things that I've seen, the different studies and white papers and things like that I've read, say that the absolute best for corrosion resistance right now is black pipe with nitrogen, and then black pipe with air, and then galvanized pipe with nitrogen and galvanized pipe with air. So FM Global is still not requiring, but they still recommend galvanized pipe to be used. Is there something that FM Global is just not seeing, or have they just not done the studies themselves yet?
No, FM has done quite a bit of study on the subject of corrosion. As a matter of fact, I'd recommend people who are further interested in the topic, if they want to read more on it. They actually recently revised their, so everyone's probably familiar with their 2-0 data sheet, which is related to fire sprinkler system installation. But they have a smaller data sheet that's a 2-1 that actually specifically discusses corrosion in fire sprinkler systems. And so what kind of where they started from, 20 or 30 years ago, was they were going to require galvanized pipe. As most people know, they just tend to have more stringent requirements than NFPA does. And so they believed at the time that galvanized pipe was a superior material of construction. They were going to require it. It kind of became, if we go back to myths a little bit, it became so kind of prevalent that some people were under the impression, or some people may still be under the impression, that galvanized pipe is required in dry and pre-action systems, when in reality, FM is the only one who actually requires it. NFPA does not. But really, FM's position is that they are still concerned about pipe obstruction and the amount of debris that is formed in a system, and it potentially plugging heads or creating a pipe obstruction. And the research shows that there will be less debris collected in a galvanized piping system than in a black steel piping system. We have a little bit different view of that topic, in that we believe that collection of debris in a system is not really an issue if you're going to start having pinhole leaks in the system before you even start getting much debris to begin with.
Yeah, the system's going to fail one way or another.
Right.
So what products do you guys have? Does Engineered Corrosion Solutions have out there to help mitigate corrosion in dry sprinkler systems right now?
Yeah, so we sell a whole line of nitrogen generators.
Okay.
We have, I believe, 7 different sizes. We have 3 different models that are wall mount. They've been, since we first introduced them, they've been a very popular seller for us, because they literally don't take up any floor space. So they're great for small applications or retrofit applications where, I mean, as everyone knows, the architect or the engineer likes to give the fire protection equipment as little space as possible. And so most people, like when you're going into an existing application, you don't have any floor space to begin with. So these wall mount models are great. They're only about 9 inches deep. They look like just almost like an electrical cabinet hanging from the wall. Doesn't require any floor space and ties right into the fire sprinkler system. And then we kind of go up the chain, and we have some larger capacity standalone systems, and those are going to be designed for providing plant nitrogen for larger facilities, whether it's a large parking structure with a lot of dry systems, or a large data center with a lot of pre-action systems. So over time, we've really, from when we first started, we had 2 nitrogen generator sizes, and everything was pneumatic or hydraulic. And now we have 7 different sizes. They're much more highly engineered, and they're all electronically controlled, can be monitored. So there's really been a huge evolution in the technology over just the last 5 years.
So I'm just looking at I'm actually online looking at the brochure. How are these generators sized? And how do they work? What's the actual process to them? Introducing the nitrogen. They work on the purging the oxygen out of the system. That's how they work.
Yeah. So inside the nitrogen generator cabinet itself, we use membrane technology, and what it is, it's just basically like a filter. We pump air from an air compressor in through a gas separation membrane, and the membrane works by separating molecules by their size. There's a bunch of fibers that are porous inside that membrane, and what happens is the oxygen molecules are physically smaller than the nitrogen molecules. And so the oxygen molecules get pushed out as a waste gas, whereas the nitrogen molecules remain trapped and provide your end product gas. And for those who aren't already aware, air is already comprised of approximately 79% nitrogen and 21% oxygen. So we're just taking the nitrogen that's freely available in atmosphere, and we're getting rid of the oxygen. In terms of how do we actually get the oxygen out of the system, like you said, there is a purging method. We use a unique method that we call fill and purge breathing. That essentially is a method of pressure cycling the system, where you have a vent installed on the system. It can be installed anywhere on the system using our method, but because it can be installed anywhere, we typically just recommend installing it at the riser. And what we do is we use a small pressure differential within the system that's controlled by the nitrogen generator to fill the system up with high purity nitrogen, and then very slowly bleed it down through a vent or purge device through a restricted orifice. And then again, it restarts the fill cycle. And so it's just a dilution process over time.
So essentially, the smaller ones come with an air compressor, the larger ones have to be paired with an air compressor. you get your fill time through the air compressor, and then the oxygen is removed from the system over how long does it take to get it to the 98% that you guys have?
14 days.
14 days. Okay.
Yes. Yeah. So we want to get it out, all the oxygen out within 14 days. It's going to provide, the least amount of time possible for the oxygen to react with the system that's already present in the system. But yes, on our wall mount units, they do include an integral oilless compressor. They can, so there's two things in terms of sizing a nitrogen generator that we look at. One is what is the total system capacity that's being supplied by the nitrogen system. And that can be multiple systems. You can feed multiple dry air pre-action systems from a single nitrogen generator. And so if you add up, all of your dry and pre-action systems, and you get a total volume of 1,500 gallons, then you look to see, okay, what model can supply 1,500 gallons? And then the next thing you're going to look at is, okay, can the onboard or integral compressor with this model meet my 30-minute fill requirement for my largest system? In retrofit applications, there's generally no issue, because a lot of times there's already an existing air compressor that we know was sized appropriately. So in that case, you can keep your existing air compressor and just drop in a nitrogen generator that's sized appropriately to provide the maintenance gas for the total volume that it's supplying. On new applications, we have to be a little more careful with, okay, does the compressor that we're providing meet the 30-minute fill requirement? If it doesn't, then you have a couple options. You can either go up in size with your nitrogen generator until you get to a point where you can meet the 30-minute fill, or you can just provide a secondary air compressor that would normally be valved off and just kind of be a backup, just used for fast fill purposes.
Okay, so that's pretty thorough. That was a pretty thorough explanation of how they work. I'm looking at the brochure. You have a lead time in here. You guys are the supplier. These systems are not available through distribution. Purchasing from you guys, that lets you guys essentially have them available for when people need them.
Yeah, that's correct. So we manufacture all of the equipment here at our headquarters in St. Louis, Missouri. And we do offer 72-hour lead times. Because we don't go through distribution, we have a lot more visibility on our workflow and what's going on with our projects. And, it's some people aren't so worried about it, especially on new construction, where you know what your schedule is. You can plan way far in advance, but other customers really appreciate that quick turn, because they may get the go ahead, the green light from their customer, maybe on a remediation project, that, okay, let's go, and I want it done as soon as possible. And right. The faster we can turn the product out, the faster the fire sprinkler contractor can get the work done, and everybody's happy. So
There's no customers like that want something
yeah,
to be
right.
done before they even ask for
They want it
it.
done yesterday. Oh, by the way, they haven't signed the contract yet.
That's right. Yeah. Okay. So, what else do you want to let all the listeners know about your product? Before we get into, I want to talk about what you guys having coming up in the future. But did we touch on everything you wanted to relay to the listeners out there?
Yeah, I think so. Really, the only thing we didn't touch on was uh, what we call wet pipe nitrogen inerting. It's essentially a higher level of corrosion protection for wet pipe systems.
Yeah, let's
Um,
actually touch on that because that's a fairly new thing that's been out for a couple years now. But
yes,
what is explain the process?
sure. So really where this started was when we first came out with nitrogen generators for dry and pre-action systems. We were having great results. We were steadily growing, but we had kind of this loyal base of customers that said, well, I've got a lot of wet pipe systems too, and I'm having corrosion issues on some of them as well. What can you do for me on my wet pipe system? And so that's when we developed wet pipe nitrogen inerting. It's the same concept in that we're trying to remove the oxygen gas from the system and replace it with nitrogen, but we have to go about the application or the treatment process differently. So because wet pipe systems, they have to have water in them at all times to be in service. So what we do on a wet pipe system is we will drain the water out of the system first, and we will charge the system with high purity nitrogen up to 30 psi. We will drain it back down. So basically empty the system back to zero, and we'll go through a couple more cycles of that pressurizing and depressurizing of the system. So basically what we're doing is the same thing that we do on dry systems, where we're pressure cycling the system to dilute the oxygen out. But instead of doing it, in very small pressure cycles over a longer period of time, because we have to get that wet system back in service as quickly as possible, we're going to do it all very quickly with much larger pressure cycles. And then we fill the system back up with water, and anything that is left trapped, any air gas that's left trapped in the system is no longer corrosive. It's a great application. We haven't seen it catch on yet very much with new construction, but it's become very popular for remediation of existing systems where people have existing wet pipe systems. They know they have an issue. They're continuously replacing pipe. They're looking for a solution. And we found that this is very successful as long as the system is maintained properly. The corrosion is essentially stopped dead in its tracks, and no longer continues as soon as you remove the oxygen.
Interesting. So that's essentially a standalone bottle that's sent out
Yeah.
with the
So
system.
you have two different options. You can use the industrial nitrogen cylinders. That's the low cost option, and probably the more reasonable option if you have just a handful of systems that you're trying to treat. But we do have some customers who are very much interested in going the plant nitrogen route, which means they want to have nitrogen on demand at all times attached to their wet systems, so that if they ever have to take a system down and retreat it, they have it right there. They don't have to worry about maintaining nitrogen cylinders on their site. They don't have to worry about somebody forgetting it or the risk of having high pressure cylinders in their facility. And so what that involves is one of our larger high capacity nitrogen generator models that is hard piped to the fire sprinkler risers. And we've seen this used in we have customers who've used this application in like a large indoor mall facilities, large distribution or warehouse facilities. And in these cases, you're maybe talking about anywhere from 10 to 50 wet pipe systems in a single building. And so in that case, you're comparing a large nitrogen generator to otherwise I need 300 nitrogen cylinders, which can be quite overwhelming.
Yes, just a little bit.
Yeah.
What do you think? Where's the future of corrosion management going? What type of things do you guys have on the coming out here soon? I don't know if you have anything that you can discuss that's not held close to the chest there, but what's the direction? How are customers in the future going to be treating corrosion and preventing corrosion in their sprinkler systems?
Yeah, I think I won't delve too much into the product side because that's we're still working on some stuff. But in terms of just the general approach for corrosion management in the future, I think what we've already started to see is some kind of codes and standard changes that have started to occur. You mentioned the NFPA 13 requirement in 2016 for an air vent on wet systems. I mentioned the factory mutual data sheet that was updated that strongly recommends the use of nitrogen in dry and pre-action and the use of air vents in wet systems. For those people who work on government projects in the United States, there is a code called the UFC, the Unified Facilities Criteria. Basically, that the military and Department of Defense use it as their standard. They are requiring nitrogen on all dry and pre-action systems. That in the United States, the GSA, General Services Administration, that controls all of the federal civilian government facilities, they are now requiring nitrogen. So what we're starting to see is that codes and standards and new product approvals, everything is pointing in the direction of greater adoption and widespread usage of corrosion management systems. So it can be, some of the conversations we have with fire sprinkler contractors who are our customers, it can be a little bit scary at first because they start to run the numbers and they realize how much money they make on their service side repairing systems and replacing pipe.
Mm-hmm.
So that's never going to go away. There's always going to be systems out there that need repair, that need some new pipe. But really the way the industry is going and the way that the kind of the owners and the engineers are looking at this is that they're going to be gradually becoming more and more proactive about this. And you're going to start seeing more and more specifications requiring corrosion management systems, or corrosion monitoring devices at the least, where they at least want to know that they install something on a new system that tells them when they may start having a corrosion problem. And then I think just overall, from the providers, the manufacturers within the industry, as with anything else, I think we're going to continue to get more efficient with our products. They're going to have better features. They're going to communicate better. They're going to report better. And like everything is trending, even in on the residential side, we're these smart buildings and these smart homes and everything communicates together. And I think that's long term. I think that's going to be what we see with fire protection systems and fire alarm systems and building management systems and corrosion management systems. They're all going to communicate and form a more efficient system and provide a lot more information to the building owner or the property manager so they can catch things before they become problematic.
Yeah, there's some really interesting things coming out here. Electronic supervisory with the sprinkler industry.
Sure.
There's going to be some big jumps in the industry over the next year and a half, 2 years. Just having this podcast has kind of opened the door a little bit to letting me see what the future of fire protection is bringing out, and
Sure.
It's going to get interesting. The industry is evolving very fast, and if I've said it once, I've said it 100 times. If you're not willing to evolve with the industry is going to evolve and move on without you. So
yeah, that's exactly right. That's exactly right.
the trick is to be able to, know as much as you can about the industry, know as much as you can about the products you're installing and servicing. And it's all about just essentially, it's not so much of who can provide a certain material, it's who can service it and manage it the best.
Yep.
And knowledge is only going to help that. So,
Right.
Lucas, I want to thank you for coming on and teaching us about all the stuff that Engineered Corrosion Solutions can offer and can help for everybody, as well as just talking about general corrosion and sprinkler systems. Lucas, if anybody wants to get a hold of you or your social media, anything like that, you want to put that out there right now for everybody?
Yeah, sure. I guess our website would be a good place to start. It has a ton of information and resources, product literature, informational videos, and landing pages. And that website is www.ecscorrosion.com. And if they want to call in, they can. Our main number is 314-432-1377. And then if they want to send an email, they can just email sales@ecscorrosion.com.
Thanks again for coming on. This was a very informative conversation about corrosion in sprinkler systems.
Yeah, no problem, Chris. Thank you for having me.
This episode of the Fire Sprinkler Podcast is brought to you by Engineered Corrosion Solutions. Engineered Corrosion Solutions is the leading provider of corrosion management products and services in the fire protection industry. ECS sells direct to fire sprinkler contractors and offers nitrogen solutions for both wet and dry pipe systems. Their patented ECS ejector automatic air vent meets the new NFPA 13 venting requirement, and unlike other available products, it does not require plumbing to drain. You can find ECS online at ecscorrosion.com or email them at sales@ecscorrosion.com.